Good afternoon. I am David Chaikin with Altascale, and it was actually Som Acharya who came up with the idea for this talk. Som is an amazing guy. He's a PhD from Cornell and came through Yahoo and Limelight Networks before Altascale, and he said, hey, we answer a lot of questions from companies that are using Hive on our Hadoop as a service platform. Maybe a bunch of folks at Hadoop Summit would be interested in hearing about some of these questions and the answers that we came up with. So that was the genesis of this talk. Dennis Sheehan is an amazing performance expert who spent many years at Sun and then Netflix on cloud infrastructures. He did the graphs at the end of this presentation, and many of you know Charles. Charles was the operations manager for the 40,000 nodes of Hadoop that were running at Yahoo a few years ago. Whenever we get into answering customer questions, can always tell that Charles's ears perk up, and he is extraordinarily helpful with answering the kind of questions I'll be talking about. So who are we? During the keynote, during Arun's presentation, Rami, our CEO, was up in front of y'all, and he mentioned that we've got a bunch of folks from Google and Yahoo and LinkedIn and Netflix and Microsoft and Tibco, and it goes on, a very talented crew. And what we do is we run Hadoop as a service. So the way you buy from Altascale is you get a monthly plan of yarn, container, task hours, and HDFS storage. So we sell Hadoop in units of Hadoop. We're selling compute and storage, and it's just what you've been hearing about at this conference in terms of yarn and HDFS. And then on top of that, we load a suite of Hadoop tools, the standard tools from the ecosystem, Hive, Pig, Uzi, and so forth, and a host of other tools based on requests from customers. So before I say what I'm going to talk about, what I'd like to hear from you is, what is your interest? So could you raise your hands if you're currently using Hive right now? Excellent. OK, so we're going to get into the nuts and bolts of what it really feels like to drive Hive. And friends of mine who have been listening to a lot of the other talks say that this might be kind of a reality check on the nuts and bolts and what it's really like to use Hive and Hadoop on a day-to-day basis. So it looked like the majority of folks are using Hive. I'd like to understand the split between Hadoop 2 and previous versions of Hadoop. So how many of you are currently on Hadoop 2 right now? OK, about half of you. And those of you who are using Hadoop that's a previous version of Hadoop, please raise your hands. OK, thank you very much. So I will spend a bit of time just going through Hadoop 2 concepts, and I'll go through the ones that are relevant to this presentation. I won't spend a long time because I know that you've been hearing a lot about Hadoop 2 and yarn, especially over the last couple of days. I'll go through the tools that we use to debug Hive on a day-to-day basis. And where I really want to get are into the Hive issues and some specific problems we see people repeatedly running into as they run Hive on our platform, and some case studies, which are really those questions that customers asked and how did we answer them. And then I have some thoughts on making Hive easier to use for all of us. OK, when I say our dynamic platform, I mean us as a community. Here's specifically where people are going from and to on our infrastructure. Almost all of our customers have made the transition to Hadoop 2.2. We've got a few customers we're still migrating up from 2.05, and we bundle these together. So most of the information I'll be talking about in this talk we learned through the School of Hard Knocks in Hadoop 2.05 and Hadoop 10. Most of our customers are right now on 2.2 and Hive 12. And Hive is one of the most commonly used tools. The other commonly used tools on our platform are Pig and Uzi, but there's a host of others. And I would like to say that we are very excited about where the whole community is going. So we've got, right now on our platform, customers trialing Spark, Impala, Stinger, as we all know, is pretty exciting with the combination of Hive 13 and Tez. So all of that is going on on an experimental basis, and we expect to roll that into general availability for all of our customers. So how did we get into the position as a bunch of infrastructure nerds to answer questions that customers have about Hive? Well, the real value that we add is putting together Hadoop and the ecosystem of Apache projects that run on top of Hadoop and other tools that interface well with Hadoop. And we spend a lot of time on a day-to-day basis making sure that all of that works. At the same time, our experience is that, and this is probably the most high-level thing I'll say in this talk, is that we really want to see our customers align the business value that they're getting with the cost, especially the charges that AltaScale is sending to our customers. And what that means is we really care that their applications work and are providing value. And I'll give a very, very specific example of that at the end of this talk. But what we're trying to orient ourselves around is service level agreements that have more to do with making sure that Hadoop jobs run successfully and to completion and add business value. So although we spend a lot of our time on infrastructure, what we're really targeting is making sure that applications are running well and doing the job that they're meant to do for our customers, which means when things go off the rails and Hive isn't performing the right way for our customers, we get involved and say, hey, how can we help? The caveat here is that we are not SQL experts. We're infrastructure experts and UI experts and really love the process of integrating the platform and making it all work. So what you'll see is a bias here that's much more towards understanding what are the underpinnings of Hive and how is that working? How does MapReduce interact with Hive, and how can we get in and answer questions about Hive by understanding what's going on under the covers? OK, so here's the quick primer on Hadoop 2. So the name node is the master of the distributed file system. The resource manager is allocating the yarn containers on the cluster. We also run a secondary name node so that I don't think that I'm doing the flashing there, but I'll try to not jump around so much, I guess. We run a secondary name node to make sure that the customer's data and their HDFS is stable and ready to go at all times. And then there are the Hadoop nodes in the system, and each of our nodes right now is running a node manager and data node, and of course those are mastered by the name node and the resource manager. OK. So when you actually run a job, there's the resource manager that decides which yarn containers to provide to that application. The application master, and this is, in the case of Hive, it's the task that's running one of the stages of a Hive process. That's requesting resources, requesting yarn containers from the resource manager, and doing the local resource allocation. And then on a node-by-node basis, you have the node manager process, which is managing the life cycle of all of the tasks. And it's reporting to the resource manager on the health of the job that it is running. An important point is all of these are actual Java processes running in Java virtual machines. Quick differentiation between Hadoop 1 versus Hadoop 2. Essentially, and we really think this is important, sorry to belabor the point here, but we really do view Yarn in combination with HDFS as an operating system on top of which other applications run. So MapReduce now and Hive on top of MapReduce, or in the next generation, Hive on top of Tez, is one of the many applications that can run on top of Yarn. We're very excited that some of our customers are now running Spark on top of Yarn, and that is just the start. We've got other projects from other vendors that are starting to be used on our platform, and it's just really exciting to see this separation of MapReduce from the core of the system, and all of the differentiation and all of the new programming models that can happen on top of that. At any rate, all of this should be transparent to Hive users. You actually, when you're writing a SQL query and using Hive, you shouldn't have to know about all of this stuff. And what you'll find during this talk is that it is actually the case that we need to be, unfortunately right now, intimately familiar with what's going on under the covers. OK, so the next step is, well, what are the debugging tools at our disposal? So we Altiscale actually get a phenomenal amount of telemetry out of our clusters. In fact, we have our own production Hadoop cluster using exactly the same software releases and so forth as our customers use. And we actually take the logs from all of our customer clusters and process them to understand what's happening on the clusters. So it starts with statistics around CPU, memory, network, and disk. And then at the Hadoop level on top of that, it's distributed file system usage, resource usage in terms of Yarn containers and the number of jobs and how long those jobs are waiting. On top of that, there are the Hadoop logs themselves from all of those processes that I was just talking about. And then, if necessary, we can actually work with our customers to go in and instrument the source code. In this case, it would be Hive, SQL queries, or the commands that are running around those Hive queries. And then, once we've aggregated all of that information from clusters, we can provide that on a customer-by-customer basis. This is one of the graphs from our interface that shows memory at the top, then CPU usage, disk usage, and network usage. The horizontal axis for all of these is time, and then there's a little time bar at the top that you can use to select the period of time that you're interested in. I have to say, I have found these views to be useful on occasion. I won't really be talking about these views so much until we get closer to the end of the talk. Where we spend most of our time are in the logs that we get from the Hive jobs themselves. So this is what it looks like, and we spend a lot of time going up and down through this stack. So it starts with the resource manager user interface. To get to the next level down to the actual Hive job, you click on the application ID in the ID column. The next level down is the application manager. So all of these different Hadoop 2 concepts are actual processes running in actual JVMs, and they create logs. So to get, for example, to the application manager log, you click on the logs link to get the mappers and reducers. Click on history. So here's what it looks like when you click on the logs link on that application manager. This has information to do with the application as a whole, meaning the stage of the Hive job as a whole in our case. And this is what it looks like when you click down on that history button, and you can see the mappers that were run, the reducers that were run, the terminal status of those mappers and reducers. You can go one level deeper to look at either the mappers or reducers. So here's the example of what it looks like to look at all the mappers for a Hive job. You can go down one level more and look at a specific mapper. And you can go down one level more and finally get to the specific logs that are coming out of the Hive mappers. So now we're at the point, this is kind of the reality check. We do this all day, every day. How many of you are familiar with these screens? OK, yes, good, reality check. This is our day-to-day life. I'll have some comments about that, and maybe this talk is mostly just sharing the pain, but I'm glad you're familiar with these. OK, so this is the way that Hive interacts with Hadoop 2. Most of the slides to this point have been vanilla Hadoop 2. I've just added some commentary about when you're running a Hive job, the mappers and reducers are typically associated with a Hive stage. Hey, Craig, how's it going with the flashing? OK, sorry about that. We're working on this. Maybe this has to do with the reality check kind of tone of this talk that's not appreciated by the demo gods or something like that. Anyway, so a lot of us spend time in the Hive CLI. That's what you get when you actually type the Hive command. There are a number of other clients that can go in through the Hive server. If any of you are Hive contributors and worked on Hive Server 2, thanks. That was an improvement with Hive 12 going forward. But it's essentially the same architecture. We have customers using Kettle with Hive Server. Do I have my thumb drive? I'll bet you always wondered what this pocket was for in jeans. It's for getting your presentation to the helpful person at the back of the room. OK, so we've got folks using Pentaho Kettle with Hive Server. And we have folks using Q interacting with Hive Server. All of these are running Hive jobs in one way or another. And then that goes through the process that I talked about on the cluster, where it starts an application manager. That application manager starts the mappers and reducers. OK, so there are a host of different places to get information about Hive jobs that aren't necessarily in those mapper and reducer logs. So there are the query logs, which are the detailed information about what happens on every Hive query that's run. How many of you noticed that they were turned off by default when we went from Hive 10 to Hive 12? Yeah, OK. Yeah, Alan noticed that too. Well, so the reason why they were turned off is because the community said, rightly, we run into this, well, there's no a default way to rotate the logs, so they wind up filling the disk, so we're just going to turn them off. We at Altascale, we actually have a nice log rotate policy, and we really need these kinds of logs to answer questions from customers when customers call us. So we've re-enabled them. But this is kind of on a blow-by-blow basis what happened during a Hive query. And in my slides for each one of these, I say I give an example of how these are configured. So then there's the more basic logs from the Hive client. When the Hive client is active, there's another configuration for those. There's the metastore itself will do logging. And there's yet another configuration file for the metastore to say where those logs go. Right, so one thing is that these logs are typically on the machines that are actually running the client or running the Hive server or running the metastore, and those are going to be typically different from the nodes that are running the mappers or reducers. OK, so here's the central part of the talk. I'm going to go through 4 Hive issues, ways that Hive can go off the rails, and talk about the generic solutions we have for those. And then I'll talk about some specific case studies from customers. OK, so the first generic problem is the Hive client can run out of memory. How many of you are executing map-side joins? A few of you. It's a very useful technique because you can essentially load a small table into the memory on every node that's running the Hive query. and then you can join a larger table to it, which is it's a lot more efficient than streaming both of the tables off of disk for every part of that join that you need to do. The issue when you start doing this, so it's a very powerful technique and can really speed things up when you're joining a relatively small table, like say a table of zip codes or something, with a table of every transaction you've done for the last 25 years. On the other hand, when you crank up a map-side join, you have to be careful about the JVM, Java Virtual Machine heap space, that has been allocated to your Hive client, because what will happen is your Hive client will try to load that map-side table into memory so that it can send it on down to the cluster as part of running the job. And from time to time, customers report to us, hey, I got this out of memory error, Java heap space from my client. And the first thing we always ask them is, hey, were you doing a map-side join? And the solution for this should be fairly simple. It should be a matter of setting an environment variable that says, hey, set the Hadoop heap size larger for this task. Enter Alan Wittenauer, who's sitting over there. Alan is working on a new generation of all of the bash scripts, all of the bash scripts that we use to run Hadoop jobs, and from them we compose the services that are running on the nodes and so forth. In this particular case, until the thing is that Alan's not going to get that into Hadoop 2. It's going to appear and be a lot better for us in Hive 3. In the meantime, we're all dealing, when we run the Hive client or the Hive daemons, we're running with kind of a squirrely bunch of bash scripts. And in particular, setting there's an issue with just setting Hadoop heap size, because there's in hiveenv.sh on your client machines, there is some code that's setting Hadoop client ops in a way where it's saying, oh no, you meant 128 megabytes and not whatever you specified on the command line. So for now, unless you're on our platform or on another platform where someone else can help you, you're kind of on your own. I guess we can look forward to the new functionality in Hadoop 3 that solves some of these problems. The other point here, though, is like any time we allocate memory on computers, we just need to be careful about that, because at the end of the day, how much DRAM you're using really matters. So for example, in Linux land, if you want to see the amount of free memory, you can run the free command. You have to understand that you should ignore the space that's being used by buffers and cache, because that will go down when your application is running, and make sure that you're not using more DRAM than is available to you on the machine. Otherwise, you start swapping, and those of us who have been around the block a few times know that that is not a good thing. All right. So that was the Hive client running out of memory. Sometimes the Hive task that's running on the nodes, a mapper or reducer, will run out of memory. And sometimes you'll get a diagnostic message from Hive. But this is one of the things that, to debug it, what you really need to do is dig in through that stack of logs that I talked about a few minutes ago, and ultimately get down to a message like this one here that's saying, hey, your container is running beyond physical memory usage that's been allocated to it. Your local node manager, are going to kill it, report that back to the application manager, which will tell you that your reducers or mappers are starting to fail if they're running out of memory. So to solve this problem, there are some job configuration variables that you can set in your, actually from the Hive CLI prompt or wherever else you're setting these job configuration variables. So you need to set from the node manager's perspective, the MapReduce map memory.megabytes, and same for reducers, to tell it how much memory to use. And if you do that, be sure to think about also setting the size of the heap in the Java options that are being handed over to that job configuration. I have seen a job where a customer correctly said, oh, hey, I'm going to increase the size that the containers will allow without increasing the JVM heap size. And if you don't increase the JVM heap size, then you can still wind up, the task won't get killed, but if you look at it, it'll be sitting there doing garbage collection and really not doing any useful work for you. Like I said, as a Hive user, we shouldn't have to be worrying about these things, but the reality check is that right now we do need to worry about these things. One other thing that we always have to worry about, and this is where the science comes in computer science. When we're driving Hadoop with Hive or with whatever system, we're actually running some sort of algorithm, and that algorithm will have a memory complexity. By that I mean the memory that the algorithm needs is a function, typically, of the input size. And so to be able to set the size of the heap that's running inside the cluster, at some level, it's actually necessary to know what the data size is as a function of the, what the memory size is as a function of the data size. To a certain extent, over the years, we will get much better query planners that will understand all this and handle this for us. We're kind of living in a world that's a little bit raw when it comes to actually having to understand all of this. Again, I think that it's always going to be the case if you're installing what's called a user-defined function into your query, then that's code that you've implemented, and at the end of the day, the only person who's going to really be responsible for how much memory is being used by the system is going to be the person who wrote that user-defined function. That's not something that a query optimizer can really help with. So at the end of the day, there is some hard, real computer science in the middle of this. On the other hand, having to set this parameter and that parameter and making sure they're in sync, that's something that will get easier as Hadoop and Hive mature. OK, one other out-of-memory issue. We have seen the Hive Metastore run out of memory. We, Altascale, have monitors on pretty much everything I've talked about, including the Hive Metastore. We'll notice when it goes down. We'll be able to, again, look at the logs from the Hive Metastore, see that out-of-memory issue. The problem here is that we need to restart the Hive Metastore to be able to deal with that, and that will cause a user-facing outage, however brief. So this is something that if you're doing this kind of work, or when we're doing this kind of work, we have to be in active communication with our customers to make sure that we're not causing an outage when we solve this kind of problem. OK, here's the last of the generic problems. One thing that we see a lot is Hive launching too many tasks. So for example, here is a job, Hive stage that has launched 80,000 mappers. You especially know when that number of mappers is too many because you can look at one of those screens that I showed you earlier and see the average time mappers are running. And if your mappers are only running for a few seconds, yet you have tens of thousands of mappers, you're kind of off the rails in terms of task size. This is typically caused by having a lot of files. Say you've created an external table with lots and lots of little files in the directory. Then when Hive starts up, it will kind of naturally start one task for each one of these little files. And starting this many mappers is inefficient, and what you may actually find is if you start this many mappers or hundreds of thousands of mappers, you'll start seeing the node manager and application manager and resource manager's logs actually filling up the disks on your nodes. So it's inefficient for a variety of different reasons, and there is a way around this. You can set the MapReduce maximum split size. It's essentially, you look at your total data size, and then you decide how many mappers you want, divide by the number of mappers you want, and set that to the split size. Most distros are now setting the input format to be the combined Hive input format, which will actually coalesce those files. You just have, it's a good idea to check that particular variable. So this was an actual customer job that was running by default 80,000 mappers, and by setting the split size appropriately, we got down to about 1,000 mappers. OK, so 3 case studies from actual alt-to-scale customers. One customer asked us, hey, I've been running this job for around 41 hours. It's a really big data set, but something's hung. What happened? Can you help us out? So I don't want to belabor the point. We went through all those screens that I've already showed. This is the exact link by link, blow by blow. And when we got to the bug at the end of the day, it was buried around 16 lines in a Java stack trace. It said, hey, this file does not exist. So after we dug through all of that, we got back to the customer. One thing that was strange about this is the mapper that was trying to access this file, it could never complete. That file simply didn't exist, and it was just retrying and retrying and retrying over and over again. Again, the system's mature, this immature. This is one of the ways that the system needs to mature, not just by failing more gracefully when it's hit an unrecoverable condition like this, but also reflecting that error up higher in the stack, so it's easier for customers, for Hive users to see this. The root cause of this failure was there were 2 people at our customer site, and one of them was running this job, and the other one was looking at the data for another reason and wasn't aware that this job was running. But the other user noticed that there was some corrupt data in the data set and just deleted the corrupt data. Totally doing the right thing, but not understanding the interaction of how cleaning data on one hand might send a Hive job on the other hand off the rails. So we have 2 people doing completely reasonable things, and what we need to make sure is that the systems that we're providing to these users are telling them in a useful way about the errors and responding properly to those errors. OK, here's another one. For reasons that I can explain offline, we had to restart the Hive Meta store for one of our customers. And after we did that, the customer came to us and said, hey, we're missing a bunch of directories, these particular directories in HDFS. What happened to them? So again, kind of interesting forensics. So what we did is first we dug into the name node audit log to see what had been done and when to blocks in that directory. So we found the times that those blocks had been modified, and actually found the times that those blocks had been deleted. Then so this was the particular log message that we saw to validate, yes, blocks associated with those files had been deleted. So then we used the timestamps on those logs to be able to go back into the query logs and say, well, what were you doing at that time? And what we saw was a create table, and then at some point later, a drop table. And then through reading of Hive documentation, and we read through the Hive documentation, and then we did some experimentation and found out that if you're creating a table in the directory that's actually the Hive warehouse directory. And then you drop that directory. Whether or not that's an external table, Hive feels every right to manage that directory. So that's functionally equivalent to just remove that directory. So it was an unexpected interaction again that the customer saw. And one of the questions is, well, why didn't that end up in the trash bucket? And so at the time, we didn't have trash turned on by default for Hive. Since then, we've done that, which is awesome because now we can recover from these kinds of things. But what we're finding is that our customers have a lot of intermediate data in their production jobs. So in between the different stages of pipelines, there's intermediate data that's created, and that data gathers up in the trash directory and can kind of explode the HDFS usage. So we've been talking to our customers, and what they'd like to have is the option, especially in their production jobs, to say, hey, what we want to do is for this particular job or for this particular query, we really want to skip trash. So here's a vote for a Hive JIRA that we're trying to get through to help our customers balance this issue of, I don't want to delete stuff that I didn't want to delete by mistake, and on the other hand, I don't want to blow out my HDFS with live jobs. Okay, by the way, this task involves correlating information from a lot of different logs. All of this would be completely impossible unless you're running NTP, the Network Time Protocol, with everything in the same time zone. Otherwise, it would just be impossible to correlate all of this. Okay, the last case study. A customer came to us and said, hey, we've got a query that isn't running well. Can you help us with that? And so instead of jumping in and saying, oh, we've got to do query optimization, we said, well, what's happening with this job, and started running it. So I won't actually run through all of these things. All of these things are just, remember those issues, generic Hive issues I was talking about? We actually, for this customer, had to go through each of those issues, but we've seen them so many times, we're like, OK, check, 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 get through all of the out-of-memory issues. But then we wanted to know, well, how is this job performing? And let's look at MapReduce to see how this is performing. So we actually wrote some internal tools. In fact, it was Dennis who wrote these that parsed the job history files and plotted mapper and reducer execution. So there are two stages. So I'll show mappers and reducers for two stages. The vertical axis is the parallelism out of the cluster in terms of hundreds of parallel jobs. So the top here is 300 parallel jobs. And the horizontal axis is time. And each of those ticks, there are about 5 ticks to an hour. So what you see here is mappers running pretty well in the first stage. There's kind of a linear distribution of mapper times, and then a uniform distribution of the time it takes the mappers to complete. And they all kind of complete at the same time. And then we looked at the reducers. And the reducers are even more uniform. So we run with high parallelism for a while. And then almost all of them complete, except there was one single reduce task at the end that still needed to complete. We looked at the second stage. The second stage had good parallelism throughout. What we found is a very common pattern. There was one reducer running for a huge amount of time, and it turned out that that reducer was processing data related to an error code. And that error code was, I don't know which user this is. Or some of you may be linking, say, to geographical data. And you often have a bucket in your data that's, well, I don't know where this person is. This is a very common pattern. And what you often see is one of these reducers in your Hive job running for a really, really long time. And then when you see that, what you need to do is you need to differentiate between I don't know about the data in this bucket, and I don't care, meaning I don't need to waste any processing time on this at all. Or you have to say, I I don't know this particular column, but I still care about the data, in which case you need to find typically a second key to partition on to balance the work across mappers, or in this case, the reducers. So just some conclusions. We're all living the life, it seems. Hadoop debugging can get very complex. We need to join data against various logs. All of that will mature. We will get to the point where those logs are more uniform, easier to correlate. We will be able to get to the point where we can surface errors in a more context-specific and a way that we can interpret them better, and Hive users can interpret them better. One thing that we keep running into is the static partitioning that's induced on us by Java virtual machines, meaning we have to set the heap size, and we better get it right. That's something we should be thinking about as a community. What solutions can we come up with so that the users in the community don't have to turn all these knobs on all of the nodes exactly right? When I look at us as Hadoop as a service, what we're able to do is kind of aggregate all these questions that we get from different customers, find the patterns, and I think that we'll be able to contribute expertise and maybe some tools back based on that expertise. And then finally, we need to learn from the traditional database community. Query planning needs to get a lot better, efficiency, the ability to surface errors, the ability to detect errors. One thing that gives me a lot of hope in this area is if you look under the covers at the Stinger project, Hortonworks has been working very closely with Microsoft on Hive 13. And the folks at Microsoft are in particular people with great and long-term database expertise. And it is just amazing to see that community coming together with the newer Hadoop community and the newer Hadoop companies and making things run better for all of us. So that's all I had. We're probably out of time, but I'd be happy to stick around and answer questions and take your comments.